So welcome back. This is part 2 about programming logic and if statements. Now this part is all about how to think like a programmer. As a programmer, we want to recognize that we are giving instructions to the computer that will read them and interpret them in a certain way. So this is all about thinking in that manner. Just like part 1, you can join me in Colab. I'll have a link to this notebook in the description below. You can simply open that and follow along with me. So the first thing in my notebook is a comment about Boolean values. Boolean values are either true or false outputs. And if we scroll here to math logic, we'll be able to see some Boolean values. And this math logic should be fairly intuitive. We have the greater than and less than sign. For equal to logic, if you remember back in part 1, we assign variables or define variables using a single equal sign. However, when we're asking Python to compare one value to another and ask if these two values are equal, we want to use a double equal sign. And if we're asking Python to compare two values and tell us whether these are not equal to each other, we use the bang equal sign. It's an exclamation mark, but in programming we call it a bang. So let's play around with some of this math logic. If we say 3 is greater than 6, we of course know that this is false, and if we run the cell, Python also knows that this is false. If we switch it up and say that 3 is less than 6, Python says that that is true. We can ask if 3 is equal to 6, run that cell, of course Python tells us that is false. We can ask if it is not equal to 6, run that, and Python tells us that it is true. 3 does not equal 6. Now, if you remember in part 1, I stressed that text strings are not numbers, and they cannot be calculated. For example, if we have a string of programmer, we can ask Python if that is equal to the string programmer. If we run that cell, Python says it's true. These two text strings are exactly the same. However, if we change a letter, such as changing this capital P to a lowercase p, run that cell, Python tells us that these strings are not equal to each other. Python recognizes that a capital P is not the same as a lowercase p, and therefore it tells us that these strings are not equal to each other. Alright, let's scroll to our if-else statements. And this is where we really get to play around with some logic. And I've written the basic logic of an if statement in that first comment. If A is true, then choose A. Otherwise, choose B. So let's illustrate this example by assigning some variables. So we'll say we have 5 apples, and for oranges, we can have 7. So let's ask Python to compare these with an if statement. We'll write if apples is greater than oranges. We'll end this with a colon. Notice that Python automatically indented after I pressed enter when writing this if statement. It's important to leave this because Python reads indentations in its programming. And it's pretty handy that Colab indents this for us. So back to our logic. If apples are greater than oranges, let's have this print, I have more apples. If it's not true that apples are greater than oranges, then we want to say else and give it something else to do, such as print I have more oranges. Now let's run this code. So let's go back through and follow Python's logic. We asked Python if apples were greater than oranges. So Python first compared apples and oranges. And since we assigned these values to apples and oranges, it recognized that 5 is less than 7. So apples were less than oranges. So it did not print this line. Instead, since apples greater than oranges is not true, it followed the else logic to print I have more oranges. And that's why we see this output. And great job! You have written your second Python program. It's easy, right? So join me in part 3, where we will learn some more Python basics and write another program. I'll see you there.